How many partitions does your Kafka topic really need? What happens if the traffic suddenly increases 10 times? How do you know if your brokers can handle it? So in this video, I will show you how you calculate the number of the partition and the brokers that your system really needs using only the throughput and the response time that you can expect it in your system, okay? So the first thing that we have to know is an explanation that how it's working Apache Kafka to have a common understandable of this topic, and maybe we can have the context, enough context that maybe later we can do in the calculation. Okay, in summary, Apache Kafka is an assistant to work with events in parallel. That is an idea, is to have a streaming of high waves of messages, and the idea is to be consumed in parallel, and you can have a high throughput and low latency because it will be consumed by multiple workers in parallel, and the idea is to have a fault tolerance because if there isn't a consumer that is down, it could take for another consumer that is on part of the consumer group. That is the idea, okay? But it's work to event driven, right? Okay, so there are multiple components that Kafka have. You have to understand what is the producer, the topics, the partitions, the broker, and the consumer group. Okay, I have an example of how it's working internally at Kafka. Okay, so maybe we can focus in this part. Okay, in the left side, maybe we can see that this is the part that is generated by the producer. The producer will generate a topic. Topic is like an event of your system. Take a note that it could be like a creation of something, delete or remove something, or some updating of something in your system, right? But that is in Kafka is called like a topic, but it's like an event in general, okay? So this topic has to be handled by the broker. The broker is have the responsibility to take the topic and store it in a partition. The partition is like a document of multiple logs of these events, and there is an offset to tracking the number of the topics that is already consumed or processed. So the idea in this partition is that ensure the order of this message to be consumed at the same time that it was created. So that is the idea. There could be the broker could handle multiple partitions, right? And only you can ensure the order in a single partition. That is the idea in general. And when already is stored in this partition, there will be in parallel or in another side a consumer group that always is watching this document that is updated. So if there isn't a new topic that is stored in this partition, there will be consumed by a single consumer of this consumer group. Okay, so that ensures that only a single consumer of this consumer group, it will take a single topic of a single partition. But the idea is that in general, okay? So we have here, for example, the list of the partition here in this side, and the consumer group will have to be in this side. Okay, take a note that the partition had to be in order, and only the head of line blocking problem here is in the side of the consumer, because the consumer is not possible to work with in parallel. It's like there will be a single topic processing in a single partition that will be consumed by a single consumer. So if you have a consumer that is processing in a single topic, it will be generated a head of line blocking, because if there is a multiple topics in the queuing of this partition, they will have to wait at the moment that the processing time of the consumer is released. So that is a potential problem that you have to take a note when you are working with Kafka. Okay, so if there is a slow message that is not processing, it will be generate more delay in the side of partition. But the good news that it will support a highly throughput, because all of the partition, all that throughput, all that request that is or topic that is created in a highly spike of traffic, right? It will be stored in this partition and not be removed. And at the moment that is released in a space in the consumer, it will take it. So it will support a highly throughput, but only if you have a multiple consumer that is prepared to support that. Okay, that is the idea. And take a note, okay, to resume that again, that if there isn't a single partition and there isn't a single consumer, there will be a sequentially slow if there isn't a problem with this process's time, okay? And when, for example, if there are 10 partitions, it will consumer by 10 consumers. So we are talking about that there will be 10 processes time that is working in parallel. What happens, for example, if there are 20 partitions and only just 10 consumers? That the number of the consumer always it will be the same. So always it will be work with 10 jobs in parallel. Obviously a single consumer could take multiple partitions, but it's the same time in the case of the processing time. I mean, it will be the same number of the parallel jobs. Uh, but that the problem it could be, for example, if you have a greater number of the consumer and than the number of partitions. That's mean, for example, if you have a single five partitions and 10 consumer, always it will be only just five jobs in parallel, because there is not way that multiple partition take the same partition, right? Because it have an offset that had to be processed in order. So at the moment that the consumer already processes a single topic, it will continue with the next one. So there will be consumers that if is greater, is a number greater of consumer than the number of the partition, there will be consumer that is an idle because it's not working, right? So that is important to note. And have another concept that maybe we can talking about that ensure that even distribution and the topic keys. So this case is the default case when you have a topic and you want to work with in parallel of any topic that the broker receive, right? But what happens if you want to attach a topic with a single key, like for example, if you have an order, right, that you want to attach in the user ID and you want to ensure the order for this user action of this user. So you want to process the topics, but in order according to the user ID. In that case, we have the concept of the key of the topic. And in that case, we generate another problems. For example, in this case, if you have a list of the topics that is assigned a single key, in this case user ID, it will be stored in a single partition. And take a note that we are talking about the partition, it will be consumed in order. So in this case, if there isn't a process, there isn't a delay in the process time of this partition because this user topics, it takes time, it will affect like an head of line blocking because they're not able to consume more topics before because it's trying to first process the early topic that it was created for this user ID. So that all in summary, the concept that you have to take note when you are designing the number of partitions and the number of brokers that you want to need in your system. But you have to take note for what is the throughput expected that you have in your system. Okay, so then we have to case here that maybe we can play with a realistic maybe example. If you have an assistant that you want to support something, you have to try to calculate the number of partition. Okay, so in this case, assume that you expected that you will have a throughput of 5,000 orders per second. Each order will generate an event, and each consumer, the process time of each consumer, it will take 50 milliseconds. Each broker can take 150 partitions, and there is no topic keys. So, like I talking about, without topic keys, is that it's very easier to work with multiple consumers in parallel. There is not way that doesn't matter if there is an order by user ID, right? That is the idea in general. So the question is, how many partitions I needed, and how many brokers I need? What happens if there is a 3 times traffic spike for an hour? What happens with the queuing that it will be stored in this partition because it's waiting to be consumed. So that is the idea in general. Okay, the first question, how many partitions are needed in these systems? Okay, when we are talking about partition is like a parallelism job, right? So in this case, maybe the question is, how many parallelism jobs do you need to consume 5,000 orders per second? And that's mean, okay, that there will be multiple jobs that it be necessary to run in parallel to be consuming these orders in a single second. Okay, so the question is, how many orders to be processed in a single second for a single job? That is the question. If you have the number of the order that is consumer in a single job, you easily you can calculate how many jobs do you need, right? So that is the first question that we have to resolve. Like a single job is like a single consumer, right? So how many orders can be consumed by a single consumer? And that answer I already have here. If you have to take, you have to know that the response time or the processes time that have a single consumer, it will be 50 milliseconds for a single order. Okay, the question could be is how many orders could be consumed or processed in a single second. Okay, so if we have 50 milliseconds here, 50, if we need how many orders could be fit in a second, we have to divide it with a single second right here. So in this case, it will be 20. So in a single second, there will be 20 orders that have to be consumed. So in this case, in a single job, in a single second, there will be a 20 message. So you all easily you can calculate if you needed 55,000 orders in a single second, and for a single job you can consume only 20. How many jobs do you need it? Wait, okay, I can have the calculation here, and the result is 250. So 250 jobs is necessary to have to consume 20 orders per second. That means that it will consume totally 5,000 orders in a single second. So that is our answer. 250 partition is necessary to have, right? So that is the first question. And the next one, it will be how many blocks are needed? And obviously it's easier. If already you have that you will need 250 partition, and you already know that a single broker can take 150 partitions, and you have a 250 partition is necessary to have two brokers here. And what happens if there are a 3-time traffic spike for 1 hour? What happens that with a queuing or the topic that it will be a delay in the partition? Okay, it's easier to calculate. Okay, so 3 traffic spike means that there will be 5,000 orders multiplied per 3, right? That means that it will be 15,000. If you already know that in a single second can be consumed 5,000, for each second, how many how many how many topics it will be in delay in the partition? 10,000. So there will be 10,000 topics that it will be delayed, there will be delay, right, in the partition. And how many it will be in 1 hour? Okay, easier. Have to multiply with 3,600. That's mean in seconds a single hour, right? And the answer it will be there will be 36 millions of topics that it will be deleted, and you have to take a note that maybe you need to increment the number of partition only to ensure that if there isn't a spike of traffic, right? So that is in summary the idea. So that's all. Thank you for watching this video. Hope that maybe it could be useful for you, and you can try with some calculation in your site, and comment in the video if there is another question or another calculation that maybe you can share. Okay, so goodbye and see you later.